Good evening, welcome to Weather God's Wisdom. As always, these thoughts are mine alone, and in making decisions regarding Cristobal, please refer to your local officials, your local National Weather Service office, and the National Hurricane Center. Well, here we have Cristobal here, centered over Central America, and you can tell that the circulation has gotten a little less rigorous or vigorous over the last couple of days, and it will continue to kind of sit here for the next day or so before it gets drawn north. But right now it is gradually weakening here. Thankfully, that the rain is starting to wane over most of Central America. Really sad reports out of the Yucatan Peninsula about flooding. And as the system begins to be drawn north by a trough that is centered over the Gulf of Mexico here, you can see that it is forcing a lot of dry air into the system. The system is centered down here, but as it is drawn north, it can entrain some of this dry air into the circulation, and so that will be very bad for the system as it continues to move north. This is the official National Hurricane Center forecast. You see here that it still is onshore around midday Friday, and does not really this evolution has become a lot slower due to a number of reasons. We have differences in the two model forecasts, the two main models, which is the GFS, who has the system moving up here and very close to the coast late Saturday here, and effects are already starting to impact the northern Gulf Coast. And then you have the European model. If you look at that, you can see that it is much further away at this time, and that is partially due to the evolution of the overall vorticity here in this gyre that is currently dictating the system's movement. If you move forward in time on the GFS, you can see that this begins to spin down quite a bit, and there's not really a central vorticity maximum. And if you can compare that to the European model, you see that there's a central vorticity maximum here, which maintains the kind of centered area of circulation here, so it doesn't become fragmented or spread out over a large area. It still is very spread out, but it's much less, it's not as far distributed as the GFS has it. As you can see here on the GFS, there are multiple vorticity maximums that have been spit out by the system due to the gyre kind of dictating the overall look of the system. So the European model has a very concentrated system, or a center of circulation here that is very well defined, and the GFS model does not. And we will be watching the evolution of this. Really what we can probably tell is by tomorrow morning whether or not there are multiple vorticity maximums that are located in the main gyre of convection here, and that will help determine, one, how fast the system moves, because GFS brings this up much faster than the European model here, and you can see that it's already much further along and it's much more spread out and much more broad. You can see that this wind field is very large and not really well organized here. You have multiple vorticity maximums and a central vorticity maximum that's not too overwhelmingly strong, which makes for a very sloppy looking system. And one thing to note about how sloppy the system may be, if it is a very spread out and disorganized system, it will be easier for dry air, the dry air that is immediately to the west, because of this trough that is here, to get entrained into the system. So we really do need to watch the evolution of the core of the system, because at this time on the European model, you can see that it is much further southwest than the GFS model. GFS model has it much further northeast, and it progresses much faster than the European model. The European model has, and again, the European model has a much more organized system, albeit broad, but overall the system is much more organized even though it is large and not super strong, GFS actually has a little bit stronger vorticity here, and that's partially due to the GFS having a little higher resolution. That the GFS, as you can see, moves this thing much faster because it is getting caught by this trough a lot quicker due to its kind of spread out nature. But the European model evolves this much slower, and you can see at 3 days out, European model still is well offshore, and effects are only just starting on the southern Louisiana coast. And what this is important for is that as we look at the steering evolution here, well, let's go to day 3. You have this ridge that is centered over the central United States, and it is allowed to kind of block Cristobal and move it further west. And on the GFS model, it's a little too late for this ridge to really do anything for Cristobal and bend it to the left. And so that's why there are vastly different landfall points between the two models, because if you go to landfall on the European model, you can see that it's near eastern Texas and it's on southwest Louisiana because this ridge is allowed to steer it around it. And that just does not happen with the GFS. The GFS bends it left when it's inland, which doesn't really allow it to strengthen as much as the European model does, because if you look at the European model when it makes landfall, you can see that the system is able to tighten up a little bit, and what we need to watch is really what happens in the next 24 hours, because you see that the European model still has a central vorticity maximum, while the GFS does not and has it much further to the east than the European model. And if I'm willing to bet on this, I'm probably going to go with a kind of compromise between the two models, because the GFS has shown a pretty extreme easterly or an eastern component to the system that hasn't really happened as much, but on the same token, the European model has been too far west for like most of this system's life. And so what can happen here is probably something that's in between these two. But in terms of structure, we'll just really have to watch the evolution of the center of circulation here and see if it actually, broadens out. And as we look at the visible loop, you can't really tell too much of if it's broadening out or not. There's not a whole lot of evidence that is suggesting that there may be some local vorticity maximums, which are hinted at by the GFS, that may be starting to take shape here. But right now, there's nothing that's super commanding that could take, the center of circulation that Cristobal has right now and displace it further to the north. Nothing too commanding. It may be developing, but it's not overly taking or overtaking the system right now. So we will continue to watch this. That is all for now. Thanks for watching.